All right. Very good morning. Very good evening, everyone. All right.
Morning, sir.
Uh, Again, please excuse me on my voice is not better. Uh, it become worse today because of the cold and throat infection. Uh, yeah. I'll try to manage somehow today. I'll try to get better by this weekend. Yeah. With that, we can just get started. I will just try to cover what all we discussed yesterday, and then we'll continue uh, with a few more topics in today's session. All right. What we did yesterday, we started with the introduction about myself, and I'm your instructor. Then I gone through my overall career experience and my areas of expertise, and then we started with the course curriculum. What is the course structure? What all topics will be covered? Uh, I'm gonna quickly show one more time. Right. So this is our course curriculum, the course content. I'm not gonna explain one more time, but we detailed discussed in yesterday's session. If anyone missed, you can go and refer those yesterday session. So this is pretty much what we're gonna cover in this course: the environmental setup and networking, the installation and configuration, the architecture, the administration of a database, the storage structure, and ASM and ASM administration, multi-tenant architecture and administration, the networking, DNS and listener, and the user management and the user access privileges and backup, restore, recoveries, and the RMAN backup strategies, a full backup, incremental backup, level 0, level 1, and restore recovery scenarios, and patching. Like again, in patching, there are so many things. GI or grid patching, your database patching, and your Oracle home database patching, and OPatch, Auto. There are so many things, but I'll just keep it simple. And database upgrades, various method of database upgrade, and your data card architecture, the standby database, the switchover, failover, and your DR drill. And if your FRA is full, what you can do? Your DR is out of sync, what you can do? Different types of standby database, different modes of standby database, and some basics of shell scripting and automation and scheduling them via cron job, and export and import, export of your table, schema, table space, and database, how you can improve your export and import performance, and the specific topic on new feature, your 12C and 19C new features, and some of them are your the performance tuning, AWR report, ADDM report, ASH report, how you can run them, how you can read them, how you can analyze those reports and provide your recommendations like table fragmentation, row chaining, row migration, and how you can do a defragmentation like table mode, table shrink, export, import, and gather schema stats, gather index stats, rebuild your index, and SQL profiling and execution plan, how you can read the execution plan, how you can generate the execution plan, right? All those are your performance related issues and how you can troubleshoot and how you can provide the recommendations. And at the end, resume writing and cover letter preparation, and then interview questions and answers and the mock interview. Right. So that's a pretty much our course content. And again, this is not limited to only this much. On top of this, if there's any extra topics need to be covered, that will be taken at the end of the course. And that is subjected to everyone interest, to all are interested, and on what topics are interested, then we'll take it at the end of the course. Right. So that's the course curriculum we discussed along with the introduction about myself. And then we started with the course structure, the fee structure, and the course timing. And as I told yesterday and today are the two demo sessions. We're using this demo Zoom link, and starting with the Monday, that's 23rd September, we'll be having a different Zoom link and we'll be starting our actual classes. Right. So this is the weekday batch, meaning classes are from Monday to Friday. It will be 8:30 a.m. IST to 10:30 a.m. IST. Uh, in Eastern Time Zone, it will be 11 p.m. EST to 1 a.m. EST. 2 hours every day, Monday to Friday. And within 35 days, weekdays, we'll be able to complete this course. And again, there are some questions around the timings. Can we move it to 8 a.m. to 10 a.m.? Again, we will discuss it in our regular classes. If everyone are interested, then we'll prepone it. But for now, 8:30 a.m. IST to 10:30 a.m. IST is a fixed timing. That will be 11 p.m. EST to 1 a.m. EST, Monday to Friday, every day 2 hours. And this is the paid training. Course fee is 10,000 Indian rupees or 125 US dollar. And the classes will be conducted in online or a Zoom session. And we'll be covering 19th version. Right. So with that, we got couple of registration yesterday, and then I have added all of those registered students into our WhatsApp group. So this is the dedicated WhatsApp group for only registered student, where we'll be discussing any questions, queries, all the communications will happen through this WhatsApp group. And these are like lifetime support WhatsApp group, provided if everyone are interested and everyone are active on that group. So even after completion of this course, we'll be using this WhatsApp group. We'll ask any questions, queries, or any help. We'll be using the WhatsApp group so that if we post questions or queries in WhatsApp group, it will be benefited to everyone. All right. So apart from that, the Google Drive access for all those registered students who have made a payment and who are registered, they already got a Google Drive access. Where in that Google Drive access, you'll get a course material, all the course PPTs, workbook, software, lab access, and all those things, lab materials, and along with that previous batch recording, so that you can watch the recording in advance and be prepared. And during the live recordings and live classes, you can ask and you can interact and you can ask more questions. Right. Again, who are interested in this course, you feel free to ping me on my WhatsApp number. I can drive through, I can help you on the further payment process. I can save this course curriculum in the chat here. You can refer this Zoom chat, and also I can ping you for WhatsApp number. You can feel free to ping me or call me in my WhatsApp number for further questions or queries or any clarification. All right. So that's about the course fee structure, timings, and the payment processing. And also we discussed the prerequisites. What all the prerequisites are required. Uh, Anyone can attend this course, irrespective of you are a beginner or you are expert or intermediate or entering into this Oracle domain, or you're trying to switch from non-IT to IT background. So anyone can attend this course. And if you have a prior knowledge of Windows, Linux, and basics of SQLs, it's an added advantages so that you can able to catch up the things along with me. If you don't have a prior knowledge, so whatever, as much as possible, will be covering along with the course. But you have to put some extra effort and understand basics of Linux and SQL and Windows so that you can able to understand the course better. If you don't know, then no issues. Whatever needed for this course will be covered as part of this course. Right. And other important prerequisites is your hardware, your whatever laptop or desktop you're using. So that laptop or desktop should have minimum 10 GB RAM and 100 GB SSD hard disk so that you can able to set up a lab and practice hands-on. We'll be using Oracle VirtualBox in everyone's laptop or desktop to set up a lab so that you can do a hands-on lab exercise.
Hello, sir. Sorry to interrupt you, but 8 GB is not sufficient.
8 GB is not sufficient. Your lab will get crashed with 8 GB if you try to do setup and labs. Your lab will get crashed frequently.
Okay, sir. And I was trying to open the drive, but it is saying not request access has to be sent. I sent it yesterday. Please approve that.
Yes, I'll take it. All right. So that is the prerequisites. What is needed for this course. Right. On top of that, we started discussing few of the topics yesterday. We started with the types of databases and try to understand standalone versus rack. What is advantages? What are disadvantages? Right. I'll take a pause here. I'll wait for a minute if anyone has any questions before I proceed further with today's topic. Any questions, queries so far, guys? Before I go with for the topic.
No, sir. Please continue.
All right.
Which RAM is for extending in laptop? I mean, RAM size.
RAM size meaning
RAM name. It's a crucial. Some different types out there, right?
there are DDR3, DDR4. Right now, DDR3 or DDR4 is anything is fine.
Okay.
All right. What we discussed yesterday, types of database, uh, standalone versus rack. So we discussed yesterday types of databases, standalone. In standalone, you can see standalone with ASM or without ASM, and another one is standalone with ASM. This is a type of databases what we discussed yesterday. In rack, we have rack database, rack one node database. Basically, there are two types of databases in Oracle, standalone versus rack. In standalone, again, two types, standalone without ASM and standalone with ASM. We discussed in detail yesterday. You can refer that. And in rack also two types, rack database and rack one node database. And now what I'm going to try to cover, what are the advantages a standalone versus the rack. The very first thing is when you compare with the standalone and rack, the one you can say HA, high availability, and the load balancing and your failover. So these are your main differences in standalone versus rack. In HA is available in rack, load balance is available in rack, and failover is available in rack. Whereas standalone will not support any of this. That's the main advantages of rack, high availability, load balancing, and failover. Because of these major feature, many enterprise customer will always run their production workload, production database in rack. What is HA? What is load balancing? What is failover? Let's say here. Right. What is first thing? High availability. In case of rack, let's say there are 1,000 users are trying to connect. Automatically, rack has a built-in feature, high availability. Some of the connection will go here. Let's say around 300 connection. Some of the connection will go here. Let's say around 350 connection. And some connection will go here, around 350 connection. So the load will be balanced across all these three servers. Let's say in standalone, if 1,000 users are trying to connect, all the 1,000 users are flooded on this single server. The load will be huge, high over here. Here the load will be equally balanced. That's one of the major feature, load balancing. So one of the common interview question, how this load balancing will be done. So that is something called in rack scan. So we'll discuss in our actual rack classes what is scan and how the scan is going to do a load balancing. That is one of the major feature in rack, load balancing. Whereas in standalone, we don't have a load balancing. Your server will be overloaded, flooded with those 1,000 user connection. And the other one is high availability. So high availability meaning if these 300 users are trying to connect to server 1, if the server 1 is down, server 1 is crashed, so this 300 users will connect to your node 2 or node 3. So at any given point of time, if one server is not available, you have other servers whereas end user can connect. That is your other major feature, high availability. Whereas in case of standalone, there is nothing called high availability. If one server which is down or crashed, all these 1,000 users are impacted and none of the new users are able to connect to your database. That's one of the drawback in standalone. And the other major feature is a failover. Failover meaning if these 300 users are connected to node 1, if the node 1 crashed, and automatically these 300 users will be shifted to your second node or third node. Around 150 users will go here, 150 users will go here automatically. That's your failover. That is available in rack because of this rack supports multiple servers. Whereas in case of standalone, there is nothing called second server. If the server 1 crashed, whatever these 1,000 users who are connected, those will be automatically disconnected. Right? So these are your one of the common interview questions. What is the difference between standalone and rack? And what are the rack features? What is high availability? What is load balancing? What is failover? And then high availability is because of multiple rack nodes, multiple clustering will be able to achieve in rack. Load balancing is because of we have something called scan. Scan is able to help in balancing the load. Failover, we have something called VIP, virtual IP in rack. Because of that VIPs, we're able to do a failover. Right? So those are your rack features or the difference between standalone and rack. And those are the independent questions. What is HA? What is load balancing? What is failover? How we will be able to achieve. So high availability will be achieved because of the rack is made up of cluster of nodes. Load balancing will be achieved because of scan. Failover will be achieved because of your VIPs. Right? So that is basically a rack concept, but we'll discuss in our rack courses. But this is going to be one of the common question in interview, standalone versus rack. All right. So that is a difference between standalone and rack. And the next questions or next topic, what I'm going to talk about is database connectivity.
Okay. Sir,
Yeah, please.
so high availability and failover in the same scenario. If one instance fails, then it will connect to another node. And in failover also, this is the same. So any difference?
Failover and
HA, high availability.
high availability is one server is not available. That is for the end user connection. The end user is trying to connect to server and server is not there. Automatically connection will go to second server. That is for the new user connection. Failover is
Okay,
already users are connected and the server crashed.
okay, okay. High availability is for new users. And
Right,
failover is for current users. Okay.
right.
Today I will not ask much questions today. I think you are really trying hard to speak. I will
Yeah,
ask tomorrow.
all right.
Very, very good.
All right. So other topic I what I wanted to cover is uh, database connection. So how the connection will work? Like let's say your apps user connection and DBA connection. So let's say how this overall architecture works. So any architecture you say my database will be on this somewhere on our data center. Let's say here I have server server A sitting somewhere in our one of the data center, London or New York or Washington DC or wherever the data center or even if cloud, your database will be hosted. Let's say I have server A, let's say hostname Oracle Lab 1 dot local domain, or let's say Oracle Lab 1 abc.com, my organization, and which has the IP address, let's say 192.168.1.100. In that, I have created my database, let's say ProdDB here. So my organization is abc.com. So like take it example amazon.com, right? So if anyone want to connect, let's say I will go to amazon.com. So I can create my own account. I can go and then I can create my own account, sign in to this application. This is your application. So that application will be somewhere sitting in this app server. Right? So whatever that users, they will connect to this application server using a different method like URL, web URL. Right? Whatever I access here, this is a web URL. Or let's say some users can connect from mobile, or some users can connect from app, or some users can connect from desktop client. So whichever method, like browser or mobile application or mobile app or some desktop client or some tools. The whatever method they connect, this one or this one or this one, they are going to create their username and password. Let's say here I can go and then create my account, sign in here. I can create my own account. So let's say a few random example. I'll say one username here, Malik, and Malik password, and then John, John password, and here. So these are the users. We will be creating our username and password on the application side. So whatever this app, I can go ahead and create our own account. These accounts are called application accounts. So these accounts will be stored under this app server. Right. So these are the users at application side we created, and we are trying to access that Amazon website or your Flipkart or whatever the retail marketing you're going to access it. Those are your application server user. And then this application server, whatever built by your developer or app server admins, so those will be using a username called app user and app user password. And this user is created inside your database. This app user and app user password is created inside our database as a DBA. We will be creating this user inside a database, and we'll give that username and password to my application team or application admin. That application user and application admin will be using that username and password while deploying this application in the application server. Whatever we end users will try to access with our own username and password that application, our connection will go to app server. From app server, our connection will go to use this app user, and connection will go to database. So as a DBA, when we connect to our database, and we will see lot of connection with this apps user. And for us, it doesn't matter who are connected from the end user point of view, who is connected to our database. We don't know. For us, only one user, app user is connected and they're doing some transaction. And this Malik user might be doing some purchasing. And this John user might be doing some return. Whatever he purchased, he's putting some return request. And this Jessie is whatever she's logged into online site and she might be doing some browsing, checking for the new product. So whatever this end user, they will log in. Those all users are application users. And once they connected to their site via that application user, in the application server, they're going to use a single user. That's the database user, app user. The connection will be using that database user, and all the connection will go to my database. At the database side, it will be a single user, and as a DBA, we will see what all users are connected. We can see thousands of users are connected, and there will be thousands of transactions. Insert, update, delete. All these users, the app user will be doing it. And why this kind of application is built? Because at the database side, if there's a 1 million user using Amazon application, and as a DBA, I cannot create that 1 million user inside my database. That 1 million user is my at application server side, and whatever their username and password will be saved in the application server, and whatever their connection will be converted using this database user, and all the connection will go to my database using that single user. Same thing applicable for your banking application. Let's say we have ICICI Bank, HDFC Bank, any bank application. You log in with the online account with your own username and password. All those connections will go to application server. There will be 1 million users in the banking, and all those 1 million users connected with their username and password. Those are like application username and password. When they connect, those username and password will be converted into that app user connection, and they will be connected to the respective database. And whatever the transaction you do online, like transferring the money or no depositing some money, all those insert, update, delete transaction will be converted with the database user, and respective table will be updated at the backend database side. Right, so that is application user, how they will connect. So at the time of application deployment, as a DBA, we will create a username and we'll create a password, and we will share with this application team. And while they deploy this application, they'll pass that username and details so that this application will be able to connect to my database. For example, let's take one of our lab server here. Right. So this is a database server, a DevDB is running. Let's assume this is the backend. This is the server where my prod database is running. And inside the database, as a DBA, I can create this app user. Right. So I can say create user app underscore user fired by, right. So user got created, meaning as a DBA, I connected to my database, and then I created this application user, and then I can give this user details to my application team. So the application team will use this username and password in deploying their application, and then route all that application user connection to that respective database. So for the end user or the developers or the application team, they need a username and password to connect to database. For example, if I want to use this username, SQL plus app user followed by app password. So app user is trying to connect, but that user does not have any privilege. So as a DB again, I'll connect back to database. I can grant a create session to that app user. Right. Now let's exit and connect using that app user. And now that app user is able to connect to database. So this is the app user. So we'll create a user and we'll grant some privilege and permission to that app user, and then share that username and credential with application team. And while they deploy the application, they'll use that username and password, and they will complete their deployment. And later when the end user try to connect using the mobile or web browser URL, all the connection will converted internally with this app user and connect to my database. Meaning for the end user to connect to my database, the username should be valid and password should be valid. Then only they should be able to connect. But for a DBA, so that is for app user connection, or let's say application user, how they will connect using that valid username and password. First they will use their own username and password, that is the application username. Once they connect in the application server application logic, convert that application user into the database user, whatever that app user we created and app password. Whereas we DBA will not use this application side of sort of connection. We have a master privileges. DBA will be having, so we'll directly connect to a database. Like let's say here, I logged into Oracle and I can simply use SQL Plus as a DBA without any username and password. I'm able to connect because the database DB is created, installed by this Oracle user on this server, Oracle Lab 1. And as a DBA, I already connected to that Oracle server, Oracle Lab 1 with Oracle user. Oracle is the owner for that database, and I'm kind of a owner to that database. I'm kind of owner to my house, and I don't need any permission or privilege to connect to my database. So I can use simply SQL Plus without any user and password as a DBA. So I can able to connect. So this is called your OS authentication without any username and password. Just I use a slash and then I will be able to connect to database without any username and password, because this particular database is created by Oracle and I already logged in as a Oracle user to my server, and nobody is stopping me, nobody is asking me. I am the owner to my house. I can log in or I can go to my house anytime. That's a simple understanding. So this is called OS authentication. We'll discuss in our regular classes OS authentication, how it works, and if you want to connect with the sys user, what I can use, that will explain it in further. So I can simply use SQL plus SSDBA without any username and password. and then I should be able to connect to database. All right. So on top of that, there are few other connections like for a testing purpose, developers or testing users. So developers want to connect to my database or testing user want to connect to my database, not using the application user. So they say, I don't want to connect with application user. We already have this application username and password, but we want our own individual IDs. I want to connect to database to do some testing. And then we never share the sysdba privileges to anyone. Only DBA will be having the sysdba privileges. So for the developers or application users, the developers or testing users will create dev user one, dev user one, the individual username and password inside my database. How we created this app user. Similarly, we'll create that individual dev user and password. Very rare scenario. We never create the individual users, but there are some requirement we'll create, and then we'll share those credential with that independent single users, and they will be able to connect. Like we'll force all the developers or testing user to use application username and password for any sort of testing or any sort of development. And in few certain scenario, we go ahead and then create certain individual users, test user one and test user one. So we will share this individual username and password with respect to users, and they should be able to connect to the database. Let's say here create user dev user one identified by dev user one. Again grant create session to dev user one.
Create.
Right now the dev user can use their own individual username and individual password, and they can able to connect to my database. So again, this third option is very rare scenario. We never instate any developers or testing user to do a testing and development using their own individual IDs. But if there's certain needs, we'll go ahead and then create their individual IDs. Otherwise, we'll force the developers or testing user to use that standard app user and password what we created. We'll save that user name and password, and whatever testing or whatever development they want to do, use that user and do it. And for the DBA, we'll be having the super master privileges. We don't need of any username and password. We can directly connect.
Hello.
Yeah,
I have one question. So, like for developers and testers, we are creating the user as dev user one, but we are not creating creating any password. So, how is it like? How is the system? How does the system know what password to take in?
this is the password, right?
So,
Dev
when
user
we are yeah,
and this is the password,
okay, when we are saying identify by dev user one, so that dev user one will be the password.
right?
Okay, so we can set like identified by if we say dev user 2, so user ID will be dev user 1
Welcome
and password
one.
will be dev user 2.
This is your password and this is username. You can do welcome one,
Okay, okay,
Oracle one, two, three.
understood.
This is your password.
Okay, okay.
All right. So that is a simple understanding of how the connection works. And again, there will be a lot of confusion with many of the DBAs, like how that millions of users will be connecting to my database. Remember, we are not creating any millions of users who are accessing the retail or the banking application. Those all username and passwords are at application side. At the back end, we'll be having only one user, which will be interacting with application server and your database. And in industry standards, this is called a three-tier architecture. So this is your backend tier where your database will be hosted, and this will be middleware where it's a middleware where your application server will be deployed. And in the backend tier, it may be Oracle database, MS SQL, MySQL, PostgreSQL, Cassandra, any database. The database hold the data. And middleware will be any application server. And it may be your Apache, or it may be your, again, that's what we showed here. It's a three-tier architecture. So this is a backend called database tier or data management tier. It may be any database, Oracle, MS SQL, MySQL, and this will be your middleware or middle tier or app server or web server or Apache or Tomcat, anything. And this will be front end. Front end will be the client will be accessing via web URL, mobile, or it's called presentation layer. They can use the browser or URL or the mobile application or any client application. This is your standard three-tier architecture. Any application or any business will run in this three-tier architecture. All right. So with that, as a DBA, we are not worrying about this front end. We are not worrying about this middleware. And what we are worrying or what we are managing in day in and day out, how this particular server is behaving. Is this server has enough resources, a memory, CPU, storage, how this particular database is behaving. Is this database is working fine? Is this database has enough space? Is this database has all the valid users and passwords? And is this database working healthy? Is this server is working healthy? That's our DBA job, to maintain this database server and to maintain this database. That's a DBA job. So we make sure that my database is available 24/7 support. My server is available 24/7, and that's what we do every day, day in and day out. So maintaining that server and maintaining the database, that's a DBA job. Right. Let's focus on the database. Further, I'll go now inside database. So any database you take, whether it is a standalone database or whether you take a rack database. So your database will be made up of instance and database. This is your database server, maybe let's say standalone server or rack server, or you can say a database architecture. So your database architecture, maybe standalone server or rack server, is made up of instance and database. Whatever we are doing, instance and database, two things. So that is your overall architecture. Your database architecture is a combination of instance plus database. So instance is a logical structure. Database is a physical structure. Whether it's a standalone or rack doesn't matter. Instance is a logical structure and database is a physical structure. Physical structure meaning uh, physical files or OS files or data files, or you can call it anything. And the instance is a logical structure. So you just think of anything, we call it as a logical, that is virtually available, and we cannot physically see that. So the instance is a logical structure which is a combination of memory plus some BG processes. So in order to show here in our lab, Oracle Lab 1 is a server, database server, and in this database server, let's say this is our lab 1. In this lab 1, we have DevDB. This is your instance. Instance is a, as I said, logical structure. And this DevDB instance is a logical structure which is made up of memory plus some background processes. And this instance is always working with DevDB. This is your database. So this particular database is a physical structure. So you can define your database name as Malik, instance name as Oracle. You can define database name as India and your database name as India and instance name as Oracle. Both are independent names. Instance name is an independent name. Database name is an independent name. For me here, I put both are same. DevDB as an instance and DevDB as a database. Any database architecture or database server will be having two things, instance and database. Instance is a logical structure and database is a physical structure. Logical structure meaning made up of memory and background process. And in this Oracle Lab 1, I have this DevDB instance and DevDB database. So this DevDB database is a physical structure. I can go and I can see the physical files. Let's say I'll connect to my database, select name from Whittler data file. So these are my physical files. Physically, I can go to that location and I can see all those physical files. Syssoc, system, temp, undo, users. We'll discuss in our regular classes what are these files. Any database you create, these are mandatory files will get created. We'll explore more on this. What are these files and why we need it? What all content will be stored on these files? We'll store it. We'll discuss it. So U01 app Oracle Data DevDB is a database name and which will be having all these physical files. That's your physical structure. That's the database. OS files are the backend files. You can call it anything. Actual data will be stored under the data files. In order to access this database, we need something called instance. Give me 1 second, guys. All right. Sorry for that. Okay. So that is a physical database of the physical files. So in order to access the database or the physical files, you need an instance. That's a logical structure. and that instance is made up of memory and background process. And whatever we are seeing here, PS-EF grep, if I do devdb, this particular devdb is having lot of background process, BG processes, background process. If I check this PS, the processes on this server for devdb, these are the different background processes which will be running and supporting for that particular instance. If I kill that instance, all these processes will be gone. So let's say I'm going to kill one of the mandatory back. Out of this, some of them are mandatory and some of them are not mandatory. So if I kill that one, now if I check that process, right, nothing is running for this devdb. Everything is gone, meaning entire instance is gone now. We have only database. So our instance is gone now, killed. So I need to start the instance again. So I'll connect back SQL plus SSDBA, connected to idle instance, meaning instance is not started, idle. I'm going to do startup. The moment I do startup my instance, automatically it allocate the memory. You have a lot of memory component, SGA, PGA, we'll discuss in our regular classes. But the moment you start the instance, it allocate the memory and it will start the background process. And you can see here, your system global area, SGA, fixed size, variable size, database buffer cache, redo buffer, and your memory is allocated and your database is started, and a lot of background process also get started. If I see this command now, there will be a lot of background process will be get started here. So that is your a logical structure. Instance is a logical structure made up of a memory and the background process. And your database is a physical structure, which is actual data will be stored here. Any end user do any transaction, the data will be stored under the actual database, under the data file. So in simple understanding, these are your common entry questions. What is database? What is database architecture? What is instance? What is database? So again, there will be a lot of things we'll discuss in our regular classes. Instance is made up of memory plus BG process. Just keep it simple. And in the memory, we have SGA plus PGA. This SGA is called shared global area or system global area. This PGA is called private global area or program global area. This SGA internally contain shared pool, large pool, Java pool, database, buffer cache, redo buffer cache. Right? There are so many components. Right? Your instance is made up of memory plus background process. That memory is made up of SGA and PGA. That SGA is called shared global area, system global area, and that SGA, shared global area or system global area, contain internally sub-memory component like shared pool, large pool, Java pool, database buffer cache, redo buffer cache, stream pool, and many other things. And your PGA contains internally UGA, user global area, and you have a stack space, and you have sort area, temp area, bitmap area, and cursor area. So inside PGA, there are so many sub-memory component. Again, don't worry at this point. All these individual component will be defined and explained in details in our regular classes. But this is your how architecture looks like. So if somebody asked you in the interview, can you brief about database architecture? Many people will get confused from where to start. So if somebody asked you the question, can you brief or explain about database architecture? Your answer should be database architecture is a consist of instance and a database. Instance is a logical structure which is made up of memory and background process. Database is a physical structure which is a backend files or data files or the storage files where the end user data will be stored under the data files. And this instance is a combination of memory and background process. That memory internally contains SGA and PGA. SGA is a system global area or shared global area. PGA is a program global area or private global area. And these SGA and PGA again internally contain sub-memory component. Again in SGA, shared pool, large pool, Java pool, database buffer cache, redo buffer cache, stream pool. All these are sub-memory component inside SGA. And a PGA again contains so many sub-memory component like UGA, stack space, sort area, temp area, bitmap area, cursor area, so many other things. Right, so that is your one part of your instance memory. And this background process contain some of mandatory BG process, non-mandatory BG process. So this mandatory BG process are like SMON, PMON, DB-writer, log-writer, checkpointer. And this non-mandatory background process are your archiver, your recover, job, queue, M1, etc. Right, so in instance memory, inside memory, these are the sub other memory components. And in the background process, mandatory and non-mandatory. Mandatory background process are SMON, like system monitor, PMON, process monitor, DB writer, and log writer, and the checkpointer. Again, each of these background process has its own task, and these are mandatory. If you kill any of these mandatory background process, your entire instance will go down. And there are non-mandatory background process like archiver, recoverer, job queue, M1, etc. If you kill these processes, your instance will not go down. Let's say here, so PS, the processes, these many processes, mandatory and non-mandatory. So this says PMON, this is the process ID. So I said a PMON is a mandatory background process. So I kill that PMON, kill -9, 8743. So 8743 is a PMON background process. The moment I kill that mandatory background process, my database instance went down. DB nothing is running here. And if I connect, it will be connected to idle instance. And I have to start that instance again. So any of these background process you kill, SMON, PMON, DB-writer, log-writer, checkpointer, your entire instance will go down. Apart from this mandatory background process, there are so many other non-mandatory background process. If you kill them, your instance will not go down. Let's say here, DB, we have these many non-mandatory background processes. So I'll take archiver, or I'll take recoverer. I'll take any one of this. Let's say they take this archiver process. This is the process ID. Kill -9 killed. And let's say PSFNF grep archiver 1, that's killed. And if I take for archiver 2, we have archiver 2, but archiver 1 is killed. And still your database will be up and running. I'm able to connect. Right, so those are your non-mandatory background process: archiver, recoverer, job queue, memory monitor, and there's so many other background process here. Right. So that is your definition of database architecture, which is a combination of instance and database. And in instance is the memory and background process. In memory, SGA, PGA, and in SGA, so many subcomponents. In background process, mandatory and non-mandatory background process. Right. And coming to database, instance plus database is your architecture. The database is actually your physical structure, which is a combination, or you can call it as a backend storage or end user data or data files or physical files, or you can call it as a storage files. So these all are referred to your database, right? So these data files are many. We have system data file, sysocs, undo, temp, users, so many data files. So each of these data files have its own unique functionality, its own data will be stored. We'll discuss in our regular classes what are why we need these all data files. Right. So I'll take a pause here, or any questions so far, whatever I covered. All right. Right. Let's take one more topic. So we understood now the instance and the database, and we understood rack versus standalone. What are the advantages? And any users can connect from database, and all the connection will any user can connect from application. All the connection will go to application server. From application server, connection will go to your database, the backend storage. Let's say what all transaction a end user can do. So end users who are connected to database, he may be doing some insert operation, he may be doing some update, or he may be doing some delete, or he may be doing some create table. Like, let's brief it in detail now. So I have this lab one server. In this lab one, I have this instance, and then I have this storage database, data files. This is my database. All these database are like your system, sysocs, whatever these data files. data files. And this is your instance. Again, this instance is made up of memory and BJ process. Let's say you have smon, pmon, debrighter, logwriter, checkpoint. Your smon, pmon, debrighter, logwriter, checkpointer, background processes. And in the memory, we have HGA plus PGA. Right, there's two memory component. So PGA will be private and end user. Like any user, like let's say client one connected, like connection meaning uh, this Malik user is connecting through web application, or John is connecting to web application, or this Jesse is connecting via web application or mobile. Any of that user connects, the connection will not directly go to database. Always any connection, any transaction they do, the end user connection will always go to instance in the memory structure. From the instance, this background process will help in reading the data or in writing the data. I'm just giving a random arrow mark here, like from here data will be returned to data files and data will be read from the data file. Like client one is creating a table, like employee table, like he's doing some create table. Client one is connected to my database, is doing some create operation, like employee name, employee ID, and salary. He's creating this table. The connection will go to my SGA and he will create this table with the help of this background process. That background process will put that data and that table will be got created on this data file. Employee name, employee ID, and salary. And client 2 will connect to my database, that will be database instance, and is doing some insert operation in that table. Let's say doing insert employee name A, salary employee ID 1, salary 1000. And the transactions will be returned to the memory. Employee ID A, employee ID 1, and transaction is 1000, salary is 1000. So he's writing some data in the memory. Temporarily, he'll be write the data into memory, and later this background process will help take that data right into the data file wherever the table is stored. Let's say this table is stored under this data file, and that data will be returned. Employee ID 1 and salary 1000. Like he is doing some create operation, he is doing some insert operation, and client 3 will connect. He doing select star from employee table where employee ID equal to 1. He doing sort select operation, reading that employee ID 1. And then if the employee ID 1 information available in the memory, like this background process will provide the details. Not this background process, there are so many other background process will help give that details back to that end user. If the data is not available in the memory, this background process will go to the data file and get that particular result back to memory. From the memory, given that result to that end user. Right, that is your select. Let's say right now the employee ID, the client 4 will connect, and again they will connect to this memory, and then he's doing a delete that employee ID 1. The moment he do delete, so this background process will go to that respective table and they're going to delete that particular entry from the table. and maybe client 5 who connects. After connecting, that employee table not needed anymore. Drop that employee table. That will be drop. Right. So those are your expected operations. Maybe create, insert, update, delete, drop. Any of those operations they perform, all those operations will be performed on the instance in the memory. To do that operations, all the background process, mandatory, non-mandatory, and some foreground process, which will help in reading, writing, creating, dropping all those operations from your database. Right. So all these transactions we'll discuss in our regular classes in details. How this select query works, how this insert query works, how this update, how this delete drop query works in details. What are the background process which involves in performing these transactions. All right, I'll take a pause here if anyone has any questions so far. Right, there's a question in the chat here. Is the recording will be available for any validity or revisit? We talked about the site. Every day sessions will be recorded and uploaded to Google Drive, and those will be available for lifetime support. And even you can download, like, this is what we discussed yesterday. So you'll be getting a Google Drive access where you have course materials, course content, PPT, workbook, lab exercise, and also we'll be having all the previous batch recording. You can watch well in advance and attend the live classes so that you can ask many questions and make it interactive. And also this current batch recordings will be available. So there's no restriction. These will be available for lifetime access. Even you can locally download into your laptop. No restriction on that. You can download locally and then keep it with you. All right. So with that, I'm gonna take a pause for today. I'm not gonna continue anything further. I'll just wind it up.
Excuse me, sir. I
Yeah,
have a small question. So,
yeah.
in this end user transaction and all, what a DBA role is there? Means it is the automatically done everything. What a DBA will do? Means if I think of that, what
Is
is the
the
role?
transaction going fine? Is the transaction getting stuck? Is that end user transaction he's doing and the end user expectation is to complete within 1 minute, within 1 second? The transaction will be hanged for 1 hour, 30 minutes. Like, you're doing an online transaction and you're doing some bank transfer and you transferred and you click submit and the transaction will be keep rotating. And is end user is willing to wait. And as a DBA, we need to make sure that our database is available 24/7 support, and any transaction should not be hang. Any query he run it, it should be getting the data immediately. And at any given point of time, our database should not crash. And 24/7, any user is trying to connect to database and he should be able to connect. So we need to do that administration of our database. Make sure that your database is available and your database has enough space, enough storage, your database has enough memory, enough CPU, enough RAM, and there should not be any interruption for the end user transaction. All those administration maintenance will be done by a DBS. That's where the course. So these are your backend activity, what you do. You're doing some maintenance. Regularly we do patching because just creating the database is not enough. There will be a lot of bugs, lot of vulnerabilities, and your database will be hacked by some hackers, ransomware attack. So for that, we regularly do a patching, make my database secure, and do enable some auditing, do enable some complex setup. For that, we do shutdown, startup, do some regular maintenance, and we do this regular resizing of all the backend data files. And we talked about these many data files, and these data files will be of 32 GB, and this data file will get full. If there's a lot of users are doing transaction, these data files will get full. When the data files are full, none of the end user can do any transaction. And regularly we need to monitor this data file size. Whenever this user data file is full, 32 GB, I have to add one more user data file. Then only the end user can do the transaction. That's your database growth. You have to monitor, keep monitoring your database growth, understanding your segments and database growth, and keep adding the data files, keep cleaning up that data files and the performance and your HGA, PGA. So if you don't have enough SGA and PGA, end user transactions will be hang and they will not be able to do any transactions. And sometimes the end user will not be able to connect to your database. That's your listeners and TNS. That is the networking. And that end user will not be having the transactions. Like, that end user will not be able to do the transaction. He is unable to see the data. Right? We'll be able to do that user, what all privileges, what all permission he has it. So what's the DBA role? So let's say your database is running on a server and there's no guarantee server can crash anytime. Your database can crash anytime. Your instance can crash anytime. And one of the junior DBA can go ahead and then delete this data file. Or there's a OS corruption, storage corruption, this data file will get corrupted. Moment this data file get corrupted, your entire business is down. Right? So how we can restore and recover your database? That's where the backup strategy will come into picture. Right? So DBAs are the backbone for any organization. If we DBA don't maintain, manage our database, entire business will be down. And that's a power of DBAs. So any organization growth or any organization everyday functional things all depend on DBAs. So if we don't maintain database properly, and business cannot run it. All right. That's a simple answer to your question. But yeah, once you start exploring, you will understand what's the importance of DBAs and how critical DBA role will be. And that's where your developer can work on weekdays and he will not work on weekends. And even he can work for 1 hour and do a coding and he can go off. But as a DBA, if I work for 1 hour and then go off, my business cannot run. DBA support will be 24/7, irrespective of weekend, weekdays, day and night. The DBA should be there to support database. That's a critical to our the business. That should be available 24/7. All right. With that, I'm gonna just pause it. I'm not gonna continue for today. We'll connect from connect from Monday, 23rd September, with the regular classes, and I'll be sharing the Zoom link, and I'll be sharing the Google Drive, and mostly I have added most of you guys who are registered, who are done the late registration yesterday, day first today. I'll be adding them today and then granting the access on the Google Drive. Right, so by today or tomorrow we'll be getting a detail about the Monday's class details and the timings and the Google Drive access. Stand by for my update. And if anyone willing to enroll or continue this course, feel free to ping me on my WhatsApp number, or you can call me on my cell number, and I can guide you through payment processing, and I'll add you to WhatsApp group, and I'll grant the access on the Google Drive. All right. Any further questions before we wrap it up for today? Anyone has? All right. If no more questions, let's wrap it up today. Happy weekend, and we'll see you soon on Monday with regular classes. Thank you. Thank you. Bye.